So as I mentioned here that we are having here the case we can use the Cramer rule for that one, which I have just mentioned here. This is no linear equation. I write again, and we can write here this is equal to my equation was in the matrix form A11, A12, A21, A22. This is the matrix of coefficient, and then I get here xy, and then I have the matrix of constant B1, B2. This is my linear system of equation. I write in the matrix form. So I just redefine my Cramer rule. We will be using this one, Cramer's rule. In Cramer rule, we are having the determinants. We write this matrix as A x equal to B. So I have three determinants. Number one, we have determinant of A. Determinant of A is the determinant of the coefficient A11, A12, A21, and A22. Then we have the determinant of matrix A1. What's matrix A1? Matrix A1 is we replace here our first row, first column by the constants, and our constants are B1, B2. So I can just write here this one as B1. We're having here B1, B2, and then as usual we're having the coefficient A12 and A22. So if I define my determinant of matrix A2, so in A2 what I'm going to do, I'm going to replace my second column by B1 and B2, and then my first column will be as usual A11 and A22. So I say I can find my x. What's my x? My x is equal to the determinant of A over determinant of A1 over determinant of A, and that's equal to determinant A1 is B1, B2, and A12, A22 over, we can have here matrix A11, A12, A21, A22. So if I rewrite this one, I can just write this one equation in equation form. I can write it like this one. This is my A11, A12, A21, A22, and here we get here x, and that's equal to the matrix, determinant matrix A1, that's B1, B2, and A12, A22. That's an important equation that we have eliminated y, and we get the value of x. We want to find y, or y in this case we can just say our y is equal to determinant of A2 over determinant of A. What is determinant of A2? Determinant of A2 is this here A11 and A21, and here I replace this one by B1, B2 as mentioned above, and determinant of A is A11, A12, A21, A22. Now I can rewrite this one, and we can just multiply with this, and we get here this is A11, A12, A21, A22, and here is y. This I want to change my x. This x is not the matrix. It's here is our small x, the variable. So here we can just change it, and here is y, and the right hand side we get here the value. This is A11, B1, and A21, B2. I hope that you remember that how to find the determinant. So determinant of a matrix, we are having here this one as A, B, C, D, and this is equal to this AD minus BC. So the rule is that we multiply this one with plus sign, and here multiply by minus, and that is the number we get by finding the determinant. This is the idea. I hope you don't forget this one. We discussed this one in linear algebra. So this is the idea we can get here. This is my equation number 2. Now this is independent of x. So these equations are simply, as we are having the differential equation with a constant coefficient studying before, we can have here with a variable coefficient also. It can be the constant, it can be homogeneous as example 1, and it can be non-homogeneous as in example 2. Both way it is correct. In example 3, I am going to take the three equations with three unknowns, where unknowns are x, y, and z, and we have three equations. We want to write in a matrix form, also in this equation, in the operator form also. I just write here, as we have mentioned, that we have dx by dt is equal to x dash. So we x dash we can replace one, and this we write here dx, and we have here y dash y dash is equal to dy by dt, and we write here this dy. Y double dash, we can write here d2y by dt square, and we get this equal to d square y. We take two things. We take all the values on the right hand side, the variables on the left hand side, number one. Number two, we write the operators. Number three, we collect the values of x and y separately. First we write the values for x, then we write for the values for y, and then write for the values for z. So we rewrite this one. We can get here this is equal to dx, x dash, minus x plus d2y, and we get here e to power t, right, left hand side. We take the second equation. We having x dash, get here dx, then we having y dash, 2y dash is equal to plus 2 dy. So we are having here dx. I rewrite my x more clearly, d more clearly. Then we are having here minus y. We take from the left hand side. When we get here minus z dash will come here dz. If you take on the right hand side, we can have here differential operator d, and this is equal to sine of t. We are having here the transcendental functions e of t and sine of t, trigonometric function, and then exponential function and trigonometric function. So get here y dash, we're having 3x, we take on the right hand side. First write x, the value for x, then for y is plus dy, then take y to the other side, we get 3y, minus become plus, and plus z dash, this is dz, and we having this equal to plus here, plus cosine t. So we can write take x common, and we can have the equation as d minus 1, the coefficient of x, coefficient of y is d square, and we having e to power t, and then we having dx, we take y common, we get here 2d minus 1 y minus dz, and we having in the right hand side we having sine t. And third equation we have minus 3x, minus 3 is coefficient of x, and then we take y common, get a d plus 3y, so d plus 3 is coefficient of y, then plus dz equal to cosine of t. Now we rewrite this one in the form of matrix. So we are having here this equal to d minus 1, this a11, a12, a13 is 0, a21, a22, a23 is minus d, we have a31, a32, then a33 is d, then matrix of unknown. Matrix of unknown is x, y, and z. Then our right hand side is e to power t, sine t, and cosine t. So this is our matrix form. So here I can write here this is my matrix L, matrix of the coefficients, differential operators. Here is now x is unknown, and here my f is the right hand side. This non-homogeneous differential equation we can write in this form. So there we now are in position that we have defined that we can write our differential equations in form of the operator, and then we can write in a form of the matrix, and we can just now apply our methods to solve this one. We will apply as told, we use the elimination method, and also I will use the Cramer rule to solve this one. As a note, I am going to give you the idea for the elimination. For example, I have here the linear equation, this is equal to 2x plus 3y is equal to 8, and we have here x plus y is equal to 2. This is my equation 1, and here is my equation 2. Here I want to eliminate my x or y to find the value otherwise. For example, I multiply second equation with 2 and add to the first equation. So I get here 2x plus 3y is equal to 8, and get here minus 2x minus 2y is equal to minus 4. When I solve this one, I'll get here the value of adding them. We get here the value of y is equal to 4. I put the value of y in 2. We get here x plus 4 is equal to 2. Then x is equal to 2 minus 4 is equal to minus 2. So the value is the solution of this one. We say the solution of this one is x equal to minus 2 and y equal to 4. I substitute here, then my equations are being satisfied. So I say this is a way how we can eliminate. We can have the 3 by 3 matrix. We discussed the Gaussian elimination method, and the second method Gauss-Jordan method. These were the elimination method. And a simple example I have given you how we are going to eliminate that one. We need this elimination also in case of the solving the differential equation. Now I give you the example where we apply these methods, the Cramer rule and also the elimination method to solve our differential equation.